Okay, in this video we will discuss about what you will do after getting the initial access on Linux operating system. First of all, what you will do is to gather the information related to the user context, and after getting the information related to the user, the next step you will do is find out what operating system it is running and its kernel version, like a system related information. And after that, what you will do, which we will be covering in this video, is to find out what are the different processes running in the operating system. So in this specific video we will learn how we can look up for the processes that is running on the operating system and what specific services do we need to target. So our goal should be to look for a process that is running as a root, because it has more privilege, and we will look if we can hijack that or inject into it or exploit it. So we will then get the root privileges. Let's get started. Okay, so as you can see, I am on my Kali Linux, and what I will do first of all is open a terminal, and let me just make it a little big so you can see it more clearly. And what I will do next is, so we will actually be using the PS, which just means the process status. Is like kind of a tool that helps you find out all of the running processes on your system. So we will be using this process status tool to find out the running processes. So in this we do have a different option that shows different results. So to see that, what we will do is type the MA, and this just means the manual of the process status. And if we scroll down like this, and you can see all of bunch of other flags. These are called flags. So if we use this, it will list all of the processes that are running, and you can just type the main PS and read out this manual of the process status. What I'm gonna do, just type the PUAUX. So the A over here just means this will show all of the processes that is running from all of the user. So what I mean by that is, for example, I am running some processes, me as a user. Let me show you who am I logged into. So you can see I am logged into this specific user, and if I use the A flag, what it will do is not only it will show the processes running for this user but our all users. So like for example, there is not just this account and except this, there is the root user. It might run some process, also the www hyphen data, this just run web server and stuff. Another user, we might have the MySQL run the database. So it's like very similar to the Windows, like how we have the regular user and then we have the local service, which is for the local services. We do have the network services as well, that just deal with the network services in Windows. We actually don't make these accounts, but they just come up with its own. So when we use this, it will show all of the processes from different user, and the U just mean it will show us the information like who run this specific process. It will give us this specific information, like for example, process A run with this specific user, process B run with root user, and so on. And next, the X just mean it will show the processes without controlling by a terminal. So what I mean by this is, so we do have a foreground and background processes concept over here. So the foreground just mean it is associated with a specific terminal, while the background processes like that we cannot actually see. Similar to the Windows, we actually, when we go to the task manager and see there are like multiple processes running, but we don't see them on our screen. So these are the background process, and in Linux we call it daemons. So without X we will not be able to see those background processes. So let me just clear this and type the PUAUX command, and let's see what we will get now. Okay, we got a bunch of processes that is running right now on this Kali Linux. And you can see this is the one user, this is the root user, and this is the another user that I was talking about. So you can see we got a bunch of process that is running right now. We do have different column. One is the user and these other columns as well. The first column shows us information about the user, like it just like give us information like who run a specific process. You can see this root process, this root user run this specific process. If we scroll down, we do have different user as I show you earlier. Now the second column we have is the PID. This just mean process ID, and as you might know that each of the process has a separate and different ID. So if we look at the PID column, we don't see any process that has the same PID. All of them have different process ID, and this column just show us how much CPU is using each of the specific process, and this is the memory. They just show about how much memory each of the process is using, and then these two just related to some memory related stuff, and this TTY just being terminal associated with process. So if we find out any process that has the question mark in the TTY column, it just means that the current process is a daemon. It just means the current process a daemon or background process. It is no there is no terminal associated with this specific process. So if we look at these processes, all of them or most of them has the question mark. You can see right here I am scrolling, and I think this one has the terminal associated, and in the next column, which is the stat, it just gives us information related to the service stat. Is it running or sleeping or is it stopped? So we actually do have different processes stats, which I'm just gonna show you. You can see right here on the screen, this is the process stat. This is You can see right here, this is the stat column, and this just mean the process stat give us information about the process stats. And we do have different stats, like if we see the R, it will just mean the process is running. Let me make it like this so we can see the state. So R mean running, S means sleeping, this one is like sleeping, and then D also means sleeping, but it's like waiting for the input output signal. So and the T just mean the process is terminated or stopped. That means zombie, finish but not clean up. Okay, and the plus just mean foreground process. S mean session leader. The less than sign, high priority. So I can see this just mean high priority. What does the I mean then? You can see right here, some processes have the I and the less than sign. So I need to ask this guy, and in this, or let me just, so when you type the PUAUX command and you get the result in the stat column, we some of the processes have the uh, I character and the less than sign, which just I know mean high priority. What does the I mean? So I'm gonna just change this I to this I, and let's see. So it's like a process that is not currently doing something. It's like currently in idle state. So in simple term, what this time column show is each of the processes, like it show how much time each of the process or specific process the CPU has used. It's like how much time a CPU is used by a process combinedly. And we might see, as you can see, some of the processes that might be running from hours, but we will see the time as 000. They just mean minutes and seconds. So it's mostly because they are just sleeping or waiting and rarely actually executing something. So that's why we see the zeros. So the command column is like a bit hard, so I'm just gonna explain it with these examples. Let me drag it over here, and so let's ignore this for a minute and come over here and talk about this. So when you for example want to start a program, what you will do is for example, we have this server.py file, and we since it's a Python file, we will start it like this on port 8080. So as you can see right here, Linux remember exactly what you type to start it, and this is what the command column just show us that. So if I use this command over here in this terminal, it will then make a process if I have this file, and then show this or all command. You can see here in the command section that I have used this specific command to run this specific process, and I will be able to see the full command. Okay, and now let's just go a bit deeper into this. Let me go here, and you can see, as I said, this just show the full command, and you can see some processes have the full path, the slashes, and some have the brackets. So in the bracket, what this is, these are the kernel thread. This just show in bracket, you can see over here, and these are specific function of the kernel that, like for example, this perform one function, this perform another, and a bunch of different functions. One more difference is that the normal processes have the path, while this kernel thread does not have any path. Neither the kernel thread show any path. You can see right here we don't see any path, binary path, and for the normal processes we can see the actual path. So now let's just ignore the kernel threads and focus on this command that just started the process. So you can see right here, for example, this is one command we have that started a specific process. So this is what we call the binary path. This is like this, and this is the actual script or file, and this is the argument or the flags that we use. So the binary is the actual executable program. This is the actual program in this case, okay, and the script of file is what the binary is acting on. Simple example of this is, for example, we do have a Python script that just steals some information, and to run this script what we will need is we will need to have the Python. So the Python is the executable program, and Python script is the script or file over here. So it just show the Python executable full location. This is the file or script, and these are the argument. These are like extra option flags or configuration passed through at launching or executing time. We do have some real example of that. Number one is this one. You can see both are the same. So this is the binary path of it, and this is the argument we passed when we were executing it. This specific process just start itself when we are opening the Kali Linux. As you can see, this is the parent of everything. It has the PID, and we do have other processes as well. If I scroll down like this, and you might see some of the processes. This is another command, like this is binary path of cron. This is like, I think this is very similar to the Windows we do have. We can schedule a task for at a specific time, and then it will execute. But to that Windows scheduler we call the cron over here. So this will execute it, and this is the flag that is also used with this binary path. And if we look here, it just show that PSAUX just normally cut off the full command because the terminal width is not enough to show the full command. It just cut out the full command and show a little bit of that. The Cloud has given me option that if you want to look at the full command, what you will do is the PS and AUX, and you will then use the WW command. So only then you will be able to see the full command. And I need to copy this, and let's see if we will be able to see the full command or no. So I'm gonna just type the PUAUX and the WW, and let's just see what we get now. Let me just make it like smaller so we will be able to see the full command. Okay, I think we do see the full command. You can see this is the binary path, and this is some flag or argument. Let me scroll up, and you can see these are the binary path, these are the flags, different flags. So why we are trying to understand the command section is that because sometimes some of the processes run with some credential, like for example we run this server.py. This is the executable, this is the file script, this is like some database host using the, like sometimes we do use the password with the flag to do some specific task. And since this full command is being recorded in the command column when we type the PUAUX or with the WW, we will then be able to see this full command. And once we type that and see the command, we will then be able to see these are the credentials for this specific database host. This is the IP, this is the password, and we can then ourselves log into that and see what inside that. Is it there something that can give us the root access or no? See, this is what exactly I mean. Why commands is a goldmine for security. Password passed as argument. So when we are trying to run the MySQL, we will use the user and also pass the password. So when we type the PSAUX, we will be able to see the credential, or sometimes the API keys or tokens or internal IP addresses. And in summary, the PSAUX show what program is running and its binary path, actually the executable. It's also show the argument and the flag that we saw, and is it a real program, like does it have a specific path, or is it a kernel thread with the brackets. And it might show also some sensitive information like password, API keys, and different stuff. And one more thing over here is that this one. So there is one more thing, which is the proc folder or directory. What this is, it's every process running, it's create its own directory or folder in this proc directory, and inside the proc directory each of the process id gets its own folder. Like for example, process id 1 gets its own folder, 2 its own, and so on, and each number represent the current process id. So for example, this is the process id of this process. If we go to the proc folder and see this process, there will be a folder with this name, and we will be able to go inside that and see what inside that. So what I will do is I will just type the ls proc and just show you the processes number and the folder. I'm not going to go inside them, okay, but just to give you overview, this is like, for example, this is the proc folder, this is the process id, and this is the command line. So this will show exactly the same command that used to start the process. It's like, so this is what I was trying to say. The proc is like a fake file system. It does not exist in the hard drive, but instead it lives entirely in the RAM and the kernel create it. So if I go to the proc folder and let's say I use the PID as 1 or the process ID 1, and then I go to this, I will be able to see the full command that just started the process. So what I will do now is to actually do, so first of all, let me make it clear and type the ls proc folder proc, and I am here now. These are the all of the processes, and let's say I want to move to the first folder, and now okay, I need to type it like this, proc and the 1 and like this. So I am in the very first folder, the first process id folder, and if I type the ls, we are seeing a bunch of information. So I need to see this command line. This will show the exact command that used to start this process id 1 process. So ls, or instead I will use the get cause cmd line. See, this is the exact command used to start this process id 1 process, and there are other information as well, like system call it, the process make, and its state, and some more very detailed information. So we might cover all this detail in some of the other video, but for now we are not going to discuss this. I have already went way too deep into this. So in last, our final goal was that to get the processes running, all of the processes running, and look for these. Is there any web server running Apache and the other and their version? Same as database server, custom application, and password in the command line argument that we just talked about. So we will need to look for these information. Okay, I hope this makes sense and you understood all of the stuff that I have explained. If you have any question, let me know in the comments. I will make sure to answer you, and in next video we will be talking about this environment variable topic. So I will see you in this video. Peace out.